In the previous session, we discussed clearly the Hadoop architecture, simple examples as in how MapReduce work. All these things have been very clearly explained to you. We will now get into the representing knowledge in taxonomies and ontologies. This is a very important topic, so please remember and listen carefully. We are always learning from data. I hope you all understand and agree to this one point, which I have been repeatedly telling from the first session. Data is everything in cognitive computing. The system will continuously evolve, continuously learn only through the data. So the data is the heart. If at all the system cannot use the data to understand and to evolve or improve, its performance should improve every now and then. If it is not able to do it that way, then it cannot be cognitive. What I mean is, if the system is not able to learn, if the system is not able to use the data effectively to learn, if the system is not able to use the data effectively to learn and evolve, it cannot be considered a cognitive system. A cognitive system fundamentally is expected to perform, is expected to understand, is expected to grow, is expected to improve by itself. So without that, it's not cognitive in nature. But you have to do all this, right? There is a lot of expectation that comes when you come for cognitive computing. You must have a lot of data. Big data we have discussed some time back. So it's a wealth of data that we require, and that's going to be the heart, kidney, liver, everything for the cognitive computing. And most importantly, the formats for representing the knowledge contained within the data is a major point to discuss. How is the data going to be represented? How is the knowledge contained within the data is going to be represented? And we need to also understand the process, right? Please understand, this is exactly very similar to the way like the children learn about the world through the observation experience, and most importantly, we are training the children as well. For example, I am showing the apple for the first time. I have taken this example some time back to my son. When he is seeing the apple the first time, he did not know what is it. So what I do, I teach, I train, and then I instruct as well. See, this is apple, this is how you need to cut and eat. So they are observing, they are experiencing, and most importantly, it is an instruction based update also they are getting, and they learn, they evolve, they are cognitive. Children are highly cognitive in nature. They evolve, they learn, they continuously learn, right? So we need to understand how do we represent knowledge first in this session. That's the foremost idea to be discussed in this session. So let's go about it. Computer systems is entirely different from human, but they are inspired by human. Please understand that our brain, our knowledge, our observation, our learning skill, everything is the inspiration for someone to build the computer. In computer system, as in humans like you and me, knowledge may include multiple factors. It can include multiple factors. It can go ahead with beliefs. I can believe that if this happens, next this could happen. If A happens, B could be the subsequent action. And we will have certain general amount of already given information also within us. So same is the case with the computers. And most importantly, there should be some structure. There should be some properly structured content available in our knowledge base. For an instance, you will very clearly know in your house where your almirah is, how are the dresses properly arranged in hierarchy. You will definitely keep the best of the formal dresses separately, keep the normal dresses separately, keep the colloquial and the informal dresses separately. You will have other dresses, other pairs of items separately. So it means that you have a clear hierarchy, which is nothing but the knowledge about where do you keep everything. You need to arrange things properly. We are getting relationships and rules clearly established even for our simple rack where we arrange things. This makes our life easier, right? So we need to categorize, we need to arrange, we need to ensure that it looks easy. So this is organizational structure. This is the knowledge that we gain, and this is how we maintain our everything. Take books, take almirah where clothes are there. Take anything that you have in your home, there will be a proper structure. That's the simplest way you can arrange. And coming to the computers, again, you need to have a proper structure, proper hierarchy, without which it's going to be extremely difficult for anybody. It's very, very difficult for the system to go without any hierarchy in picture. We can now think about the smartest of the people. You may definitely know some of the smartest of the people even from your classes. What really makes them smart or really intelligent? It is very simple. It is not just the memory skills that they have. Intelligence is also all about acquiring. Please understand, acquiring, you should learn. Retaining, you should remember. Analyze, you should be able to understand what the data that you have collected is all about, and develop communicate and apply knowledge. This is what is making them smarter or intelligent. People who are called intelligent will be able to listen better. People who are called intelligent will be able to retain more things in their brain. They will have faster analysis capacity, and also they will develop, communicate and apply knowledge to the things that they are seeing. So that's what is making them intelligent. One can be intelligent without knowing much as well. So there are some people who are extraordinary by birth, right? There will be signs of intelligence to them naturally. Before even acquiring some knowledge, they will be intelligent. They will be very inspiring even. So you could have seen people who are answering questions much faster, the math genius people who are solving problems just like that. They are not given with additional training, but they are natural intelligent. We have them as a separate category of people. So they can be intelligent even without knowing much. That can be a child who is answering questions so faster. So they have signs of intelligence even before acquiring knowledge. Now, on the other side, a person can know plenty of facts but not to know how to use those facts to accomplish a task. This is also there. These are the people who are bookworms. They just study and they do not know how to implement things. They may know, they may study, they would have gathered knowledge, but without knowing where to apply that, that's going to be waste of it. So there is one category which doesn't require any sort of training, but still they are very intelligent and they apply things properly. On the other side of it, a person who is really having a lot of plenty of known facts which he has collected over a period of time through reading, through learning, but not being able to apply to that in the right area is a failure. That's not something that we want. So we have to acquire and achieve real high level of cognition. Cognition is all about learning. Cognition is all about evolving. I have been telling this word for a long time now. People are system, be it anything. I can go with people or I can go with systems. They must be able to definitely connect and correlate data from multiple corpus or corpora, whatever we have. I have dealt in detail about corpus, and I have explained you very clearly in the previous discussions as well what is corpus and how do we populate corpus, all those things. Now, the people are computers. Whatever we are taking to make it cognitive, we need to be able to correlate data from multiple corpora at the same time. Please understand, they should be able to handle multiple corpora. They should be able to correlate data from multiple corpora. Now, humans actually do this easily. We are able to do this much more easily. We will be able to connect it very quickly. But on the other side of it, computers, we have to put in some effort. Let's take a very simple example. We are actually learning how to ride a bicycle. Then what we do, we process information about the weather, traffic, road conditions, and we can ride it safely when we are planning to go. This all will be done much easily by a human. But when you want to make this thing done by a computer, which is cognitive in nature, it is going to be a little challenging. So please understand the point here. It is all about what you learn. It is very more important about how do you apply the learning that you have gained over a period of time to get it more meaningful. And we humans are naturally skilled and powered to do that easier, but sometimes computers really need a lot of push. So to make it cognitive is not easy. Now we are going to get a better level of understanding where we are going to define taxonomies and ontologies. I have spoken about this in a brief note sometime back, not really in a detailed way, but now we will spend a little more time where it could be much more useful for you. Now, what is taxonomy? Very simple. I have already told you this with an example of the almirah where you are arranging the dresses. Now, let me take a very simple example again. We are going to arrange our almirah with books, and it is going to be arranged in such a way that each subject materials are grouped together. Now, engineering subjects, you may have 3 subjects in your semester. We are grouping it one after another. Say it can be engineering drawing, second hydraulics, third it can be like microcontrollers or something. So we have got 3 subject items clearly available, and we pile up content over there. We have got one subject related to yoga. You are keeping it separately away. You have got one subject which is English or your regional language learning or something. We'll keep it separate. What are we doing it? We are making it more systematic for us to understand and pull it out. We will also paste a sticker in the rack saying that this is this material, this is this subject, this is this subject. We label it. Now what do? Very simple. We go ahead and we get it more organized, and we are also making it much easier for us to manage, search and retrieve. Please understand, if we mix all of them, we may need a lot of time to go ahead and retrieve content, which is not very easy at all. But in this case, what we do is we are going to get this clearly done by getting the structure very clearly made. That's it. Now, what is taxonomy? A taxonomy is nothing but a hierarchical way of capturing or codifying information. Please remember, it is the way where we can arrange things properly. It is a hierarchical way where we can capture or codify information in the chosen field, right? So in computing, taxonomy is a simple practice where you will be categorizing and classifying the data, information or elements in a very structured or in an organized manner. Remember, taxonomy is all about categorizing and classifying data, information or elements in a very structured or in an organized manner. So that's going to help you. As I told you, it's a very systematic approach towards handling data. It is a very systematic approach towards arranging data, which will make it very easier for you to manage, search and retrieve. That's the major point that you need to understand. Now, where is taxonomy very important? Taxonomy is very important when you want information management to be very precisely done. What do you mean by that? Very simple. I have got a lot of information, which is nothing but the data. I've got a lot of data. I need to manage it properly. How do I manage it? When you have a proper taxonomy already available, proper hierarchy already available, you will be able to manage it much easier. So that's one important point that you need to understand. And content organization. I have got a document. In that document, I am covering 25-30 topics. And all those topics, if I have put it in a proper table of contents format, and then if I have called out numbers and subsequent subsections properly, it's easy for me. So the organization of the contents even can be done much more nicely when you go with the proper taxonomy and structuring the data. This is end of the day, structuring the data. You need to get it done. Now, we are going to have a simple example which is presented in your right hand side. I'll touch it a little later. But taxonomy is all about creating the logical and organized systems to manage and to access information properly. I've got a lot of information, lot of data available with me. I need to manage as well as access that information. How do you do it? I will do it through taxonomy. And very important point here is we are trying to make the system more cognitive in nature. We are trying to make the system more interactive in nature. More the interactiveness we are giving, more the interaction ability we are giving, more the ease we are giving to the user, we make it more cognitive by increasing and improving the user experience. You are going to get the information retrieval done in a much easier way, much better way, and you are contributing to the ease of handling. So that's very, very important. And we are having a very simple example here, which I'm going to show you. You can see that this is the taxonomy for the motor vehicle types. So the major topic that we have taken into consideration is motor vehicle, and attributes you can see. We have got year, manufacturer, model, color, weight. Now the motor vehicle is an overall topic, and inside that what are all the subtopics and the hierarchy which can come? It can be a car, it can be a motorcycle, it can be a commercial vehicle. And when it comes to the car, it can have attributes which are body style, insurance class, everything. When you come to motorcycle, the attributes could be engine size, insurance class, kind of vehicle, what it is, how many cc it is, all those things. And coming to commercial vehicle, it can be bus or taxi or truck. When it comes to bus, commercial vehicle, so how many people can we accommodate to make it more commercially viable? Taxi, how many seats can be there? At a time, how many people can be taken? And truck, number of axles, the gross weight, so that we can understand what is the load that it can take. Now it gives you a clear picture, as in the hierarchy starts with the motor vehicle, which is the category, and it can be further categorized as passenger car, motorcycle, and commercial vehicle. And commercial vehicle is further getting into deeper hierarchy, which include the bus, taxi, and truck. We can further go into bus, we can further go into taxi, and it will keep on evolving. Now here, it is very easy for somebody who has got no idea about how the automobile structure, how the automobile wheel will work like, how the entire wheel, entire structure of the automobile things will work like, classification will work like, easily through this understanding. This is what is called taxonomy. Taxonomy is all about getting things much easier for you. Taxonomy is all about making it very comfortable for you. That's it. Now we are getting into the next topic, which is very important again. Just a second. Right. What is ontology? Ontology is always combined with taxonomy. Whenever you talk to people, they will talk they will talk like taxonomy and ontology, but we need to understand what ontology is also. Ontology I have already discussed. I have given you the definition, but here we will just retouch it very quickly so that we can understand how the relationship is there between ontology and taxonomy. Ontology is nothing but it gets you all the information you would like to capture from a taxonomy. I have got a taxonomy. The ontology will help you. Ontology will get you all the information which you want to know from the taxonomy. And also it will get you the clear rules and relationships between the category and about the criteria for the inclusion. So when you want to know more about taxonomy, we will go ahead with ontology, which will get you more information on the taxonomy. A taxonomy is very simple, where you will actually get more semantic information, and that will help you in guiding into the decision. You will be able to get into the clear decisions when you go with proper ontology. A richer and fully completed ontology will help you in getting into the solution much more easier and solving the problems in a much better way. So it is all about taxonomy, where you are getting a clear hierarchy defined, and in the ontology it is all about understanding the content from the taxonomy, from the taxonomy through the ontology, which can enable you to get into proper decisions. That's it. This is what is taxonomy, this is what is ontology, and this is the connect between them as well, and this is a very important question. Now we are getting into the next topic, where how to represent knowledge has to be understood. So we have been talking a lot about data, we have been talking a lot about the ontology and taxonomy. So all these things have been discussed. I hope till now everything is clear. Now it's very important to understand how to represent the knowledge. We need to ideally decide on the knowledge representation scheme. We have got methods to go ahead with taxonomies and ontologies. So first thing is, you need to understand how are we going to how are we going to use, how are we going to choose the knowledge representation scheme. This is very important decision, and there are multiple approaches that one can follow, but which one is the better one? Keeping it simple. But can we keep it simple for all the cases? No, might not be possible, because some problem by itself could be very complex. So the relationships that are kind of imprecise, or it cannot be specified in full, there will be problems in these cases where you cannot make it simple. Simplicity is always good. Simplicity is the preferred design goal as well, but sometimes we may not be able to go ahead with it. So we want at least to capture all the known object types or classes. Please understand, I am pulling in classes and object types here. We want to capture at least all the known object types and classes. I underline the term classes and objects here. What is a class? Class again is nothing but which is going to define the properties of set of elements or instances. You must have learned the classes in Java, in C++, so the definition can be correlated to a decent extent. Now the class definition is going to help you in reaching the target by providing all the necessary information about the relationship or the behaviors as the system is evolving. That's a very important point. Robust representation is our target, and if it is to be robust, we need to make sure that we need to also make it very flexible, and it has to be operational all the times. So we need to consider all these points. Now I will highlight 5 or 6 important points in this section, so please try to recollect it. Domain knowledge is the point that we need to know, and inside cognitive computing application, domain knowledge is a very important concept. I have got multiple domains touched by the cognitive system. So the domain knowledge on what are all the domains that we are going to touch in is a very important point. So we can capture this information and store it properly as simple data structures or lists, or you can go ahead even with the conventional databases, and we need to keep it proper. Now the cognitive computing designers can go ahead with multiple approaches which can help in the procedural or object-oriented approaches, and these structures whatever I have been speaking about in the first point, I need to get all these things clearly accomplished through any of the methods that the designers go ahead with. It can be even through object-oriented programming approaches, as I told you, or list processing, or they can choose the way that they want to model, and they can choose the way that they want to go ahead and accomplish the task one, the point one, through selection of appropriate programming languages and tools. The tools again should be very properly chosen, because that will actually reflect the proper results. You have a lot of complex data, you have a lot of data which is with veracity, velocity, we have seen all the 4 V's, right? So when you choose the tools for all these operations, that has to be proper so that we will have appropriate operations performed. We will have appropriate operations performed without any problem with the data that we have chosen. And there can be trade-offs again. So in case you are choosing something, some tools or some programming languages, say C++ you are choosing or Java you are choosing, there could be definitely trade-offs that you need to look into. So if the trade-offs are so much heavy that you will lose the system's credibility, you will lose the system's core functionality, you will have to re-choose the platforms that you have already identified. You will have to rethink about where you can go ahead and refine things further. But this is a very important thing. There could be trade-offs, and the trade-offs are to be properly, carefully looked into. And we need to choose the contents, choose the methods, choose the tools based on the domains that you are working on. For medical, that could be different thing. For automobiles, that could be different thing. So it is important always to consider the case studies and the scenarios that you are working on before you go ahead and choose, before you go ahead and finalize the tools and the programming languages. Now, a single system actually can contain several knowledge repositories, and it will all be partitioned properly. Now, please understand, the logical design for the collection of data structures used to represent knowledge is the model. We have got models available even for the simplest of the chess game. You can see this here. This is the way we can model a chess game. If some of you play chess game, you will probably be able to recognize few of this. Now the entire game can be modeled, and the possible first moves, where will be the place, which will be the piece of coin that you are taking and moving. All these can be modeled very clearly, and this is the way we will model it for a simple chess game. Now consider the complex automobile scenarios or healthcare scenarios. Modeling will be even more difficult. That's a very important point that I'm coming to convey. Now, more difficult domains are there. Diagnostics in the automobile. I need to predict what will happen next based on the data that I'm collecting real time. So that's going to be really very tough. It's not so easy. So we will have to look into multiple things like electrical, fuel, ignition, cooling, fuel levels, air level, all those things, and more dozens of parameters are there which are to be considered. So when you are taking consideration to work with these kind of domains, you will have to model it most appropriately, and getting the interactions between these subcomponents identified would be also tougher and would be challenging. So you can see that there is one more example which is given here. For an instance, we are taking that an electrical fuel pump part of electrical system, or is it part of fuel system? This is a very confusing question. We are having an electrical fuel pump. It belongs to electrical systems or it belongs to fuel systems. What will be the answer? It's again very confusing, so we will have to think. And when the black smoke is coming out from the exhaust pipe, the black smoke could be because of an exhaust system failure, or it's wrong fuel injection, or fuel quality related things, or is it a fuel failure? And is coil part, is it part of the electrical system or ignition system? So when we talk about all these kind of complex scenarios, it is very tough for you to, it is very challenging for you to go ahead and model it that way. So you can see that we have given some examples, like when it is burning, it could be because of a rubber burning, and it can be from engine, it can be from suspension. So you can see that you need to look for belts, you need to look for tires in that case. This is the way you have to model. You see this example which I have given you here. This is going to be very easy for you to understand. When you have problems, when you have burning smell, it comes from, it could be because of engine or suspension, and then we are getting into belts and tires to identify further. And for oil, I have given similar example. It could be engine. Engine oil is the only oil structure that we are looking into the subsystem level, and it could be because of leak or spill. Spill can happen when there is a overflow, or when the roads are so bumpy it could have come out. The leak is because of holes or damages in the tank. So likewise, we need to look into all the possibilities, and we need to train our system accordingly. This is a very important aspect of understanding the modeling. To solve hard problems, we will have to use many different representations. So please understand, you will not be able to arrive at a solution right in the first shot. You may have to think a number of times with permutation and combinations going in picture, and then only you will be able to arrive at a proper system. Now we have seen ontologies, we have seen taxonomies. We are definitely supposed to know few other methods for knowledge representation. The first one is simple tree and the second one is semantic web. We'll see both of this, and probably with that we'll conclude for the day. A simple tree is a very simple data structure that will go on with parent-child relationship. Now my grandfather, grandmother were there, my father was there, my father and mother are there, I came, I and my wife, my children. The complete parent-child structure will be captured for the data, and that's what is called simple tree. If the relationships are rigid and formalized, a simple tree can be implemented as a very simple table with parent and child relationship, and this is very easy to represent. They are the most commonly used approach. The simple trees are the most commonly used approach in the data analytics in this sector for a long time now. But if the data is very good to go ahead with, we can go ahead and use simple trees. So every category would have series of elements further as well. But again, simple trees will be very easy for you to understand the logical content of the data that you are handling. So simple trees are used as one of the methods for knowledge representation. Semantic web is the next one. This is an extension which is provided by W3C, the World Wide Web Consortium. They are the ones who are working on this, and they make the web content more meaningful and understandable. In the sense, not only for you, the understandability should also go and extend to machines. Whenever you are having a web page content, that should be understandable both for human and machines. So it is fundamental idea that web content can be described and linked in a simple way that the software agents can better understand the context and establish the relationship. I got relationship to be understood very clearly, the context to be understood very clearly in the web page, and that's what semantic web is all about. There are multiple key terms that we use in semantic web. First one is RDF. This is a very important term which is called Resource Description Framework. It is a very standard format. It is approved and this is used widely. So this standard format is used in representing the data and its relationship. That's all. Subject, predicate, object. This is the way they get the tuple used. This is the tuple. This tuple is used in RDF. This is the basic foundation for linking and connecting data in the semantic web. Remember, this is a very important question. RDF. RDF, Resource Description Framework. Now coming to ontologies, I have already spoken enough about it. They are nothing but formal, machine-readable representations of knowledge, defining clearly the concepts, the relationships, and rules in a particular domain. RDF schema, which is called RDFS, and OWL, Web Ontology Language. This is again very, very important. They are the languages which are used to create ontologies. When you want to build ontologies, you need languages. So we are using OWL and RDF schema towards building, towards constructing the ontologies. So this will help you in clearly defining the classes, the properties, resources, relationship, all those things. OWL is very, very useful and it is more expressive. It provides you more features for complex domains as well. OWL is very famous and this is being used quite frequently as well. Now SPARQL. This is nothing but a query language for querying and retrieving data from RDF stores. This might look very similar to SQL. So we have it as SPARQL, which is nothing but a query language which will help you in making a query and retrieving the data. And finally, linked data. We must be aware of what is linked data already. It is into interlinking of the structured data in the web. I've got multiple data points available in the web. It is the interlinking of structured data. That's it. If you have a basic idea about what is RDF, what is ontology, RDF schema and all, SPARQL, linked data, that gets you into the semantic web. Semantic web by itself is a huge subject. So if you are interested, you can explore and do further research in this area as well. Multiple research articles are coming nowadays with machine learning and semantic web, deep learning and semantic web, and even cognitive computing is very highly dependent on all these kind of latest happenings which are growing much faster in the market. So you can have a look at it. In the next session, I'm going to talk very clearly about how do we apply advanced analytics to the cognitive computing. That will follow tomorrow. So tomorrow by the same time, you'll be able to join and